Light is the only thing you see. All visible objects either emit or reflect light. Light has been studied for thousands of years. Some ancient Greek philosophers thought that light consists of tiny particles which enter the eye to create the sensation of vision. Others thought light traveled from the eye to the object that was viewed. Up until the time of Newton and beyond, most philosophers and scientists thought that light consisted of particles. One Greek, Empedocles, thought that light traveled in waves. One of Newton's contemporaries, Christian Huygens, also argued that light was a wave. Light did seem to be a particle. It seems to move in straight lines instead of spreading out like a wave. However, Huygens showed that under certain circumstances, light does spread out, and other scientists found evidence to support the wave theory. The wave theory became the accepted theory in the 19th century. In 1905, Einstein published a theory explaining the photoelectric effect, which we'll discuss in a later chapter. According to this theory, light consists of particles he called photons, massless bundles of concentrated electromagnetic energy. Scientists now agree that light has a dual nature, part particle and part wave. It wasn't known whether light travels instantaneously or with finite speed until the late 1600s. Galileo tried to measure the time a light beam takes to travel to a distant mirror and back, but it was so short he couldn't measure it. The first demonstration that light travels at a finite speed was done by the Danish astronomer Olaus Rømer in about 1675. Rømer measured the period of orbit of Jupiter's moons. The innermost moon, Io, revolves around Jupiter in 42.5 hours. Io disappears periodically into Jupiter's shadow, so this period could be measured very accurately. Rømer found that while Earth was moving away from Jupiter, the observed periods of Io were longer than average. When Earth moved toward Jupiter, the observed periods were shorter than average. He found the discrepancy to be about 22 minutes. It was Christian Huygens who correctly interpreted this discrepancy. When you take the extra distance light has to travel from Earth's closest and furthest distances from Jupiter and divide it by this time, you get the speed of light. The speed of light is 300 million or 3 times 10 to the 8 meters per second. More accurate measurements have been made since, but the speed of light still rounds off nicely to the value calculated by Huygens. The speed of light in a vacuum is a universal constant. Light is so fast that if a beam of light could travel around the Earth, it would make the trip 7.5 times in 1 second. It takes light 8 minutes to travel from the Sun to the Earth, and 4 years to travel from the nearest star, Alpha Centauri. The distance light travels in 1 year is called a light year. When astronomers look at the light from a distant star, they are seeing light made long ago. In this way, a telescope is like a time machine. The furthest observed light to date is from about 13.2 billion light years away. This light is nearly as old as the universe itself.